today we will talk about the face detection with a native API. But before we go to the technical stuff, I want to talk with you about us, about humans. So we look at faces every single day. But have you ever thought, like when you look at the faces, what do you actually see? And how does it work that you look at the person and you know, this is Paul, this is Antoine, and it takes you very, very least amount of time to recognize the person? How do you know, looking at this slide, that this is Benjamin Franklin from a $100 coupure? The thing is that our brain has actually a secret that was necessary for us to survive during the evolution. There is a special area that all of us have, and it's called fusiform face area. It is responsible for only one thing, for recognizing faces. And that was essential for all of us, so that we look at a person and know who is our enemy and who is actually our friend. For our brain, it takes only 200 milliseconds to know that the person is and to recognize it. How it works is that when we look at someone, we don't actually check the eyes or the nose or the mouth or the eyebrow shape. We just look and we know. So the fusiform face area, it works in a way that it scans immediately the whole face. And because of that, here comes a question. How can you teach computers to recognize faces like humans? Because computers simply don't know what the face is, what the nose is. They don't know. They have no idea. And another question that comes to a mind, how do you bridge the gap between how humans perceive the face and how the computers can actually do that? So today we're going to talk about 4 things. We will briefly discuss how iPhone sees. Then we will configure the camera on our phone for face detection. Then we will do a 2D scan. And then we will do a 3D scan. And I want you to scan this QR code right now to ask questions. So maybe you come up with some questions through this talk. And I'm just scared that there won't be enough time for questions. And that's why put your questions in the GitHub discussions. I've put my code to GitHub. You can have a look at this and ask whatever you want in the GitHub discussions. Did everybody scan it? Yes? I hope it works. Okay. Okay, so now let's briefly have a look at how camera sees. So first we have a camera, but the camera cannot know. This is the eyes, this is a person, this is a chair. All that the camera has is actually a light and colors. And what camera does is that it transforms the light and colors and other noise that it can capture into numbers. Okay? Good. But, oops, what happened? How do I go back? So the camera gives us the numbers. And what do we do with that? Because the numbers that the camera is actually able to produce are pretty much useless for us. We need a picture. That's what we need. And let's look at the Apple's vision stack. First, we have a framework called AVFoundation. It's a camera framework. It can capture the light, and then it can deliver a raw picture of pixels. Sorry, I really have difficulties with this setup, but I'm trying my best. Then, when with AVFoundation we get the picture, we need to do something about it. And that's where the vision framework comes in. Vision actually is able to interpret the pixels. Inside the box, it uses ML, and it looks at the pictures and starts searching for objects like nose, mouth, eyes, and so on. Vision works in a 2D, and that's important that you remember about it. Vision is only about 2D. So it captures the light through lenses and converts. And then there is a next thing that we need to look at. Is the ARKit. An ARKit is actually responsible for the 3D scan. It builds the 3D map of the face mesh. It's able not only to recognize the face, but also to follow it. So if you turn your head like this, if you lean a little bit, blink, the ARKit still is able to follow it and to recognize the object. And then look at the face detection terms that are actually important to know. So when the camera is looking at someone, we need an area to scan it. And this is called bounding box. It's an important term for vision. When we know where to look at, then we have to figure out the objects like eyes and nose. And these objects are usually determined by this amount of small coordinates called landmarks. And it looks like that on the picture. You see the dots, and then the vision can determine the landmarks and think and suggest, this is an eye, this is a nose, and this is a mouth. And when it is suggesting that with these dots and amount of these coordinates, then we are able to draw the contour out of it and actually get a picture of the face. So what we're going to do today, as I've said, we're going to do the 2D scan and a 3D scan. Let me try actually to do it with my phone live. I'm not sure it will work, but let's give it a try. Okay. Okay. You're able to see my camera? Okay. And now it says it's searching for the face. It can see only part of my face, and this is the 2D scan that I'm actually doing. But then I'm pointing my face in here, and you could see that it has drawn a contour, so there are eyes, nose, face shape, even my mouth. You cannot see it because of my lipstick, but it's there, trust me. And then there are checks that are running. I'm running the scan, holding my face still, and then the scan is complete. And if I'm not happy, I'm actually able to rescan. Okay, and that's how the 2D scan with vision looks like that we are going to do. But there is one more thing that we are going to do today, and this is going to be a 3D scan. And let's try doing that on my phone. Okay. Again, I'm not holding my face still. I'm just showing a part of it, and now that's what I'm doing. It's not always happy. Sometimes it says that the validation failed. But now I have run a 3D scan of my face on my phone. And that's going to be one of the parts of the talk today. What are the challenges that I faced when I was doing all of this? It's important that, first of all, we want to create a session with a camera. And whenever we do a face scan, that is either 2D or 3D, what we need is a very good quality of picture. So we would need at least like 30 frames per second for our camera in order to scan a face properly. But it comes at a price, and the price is that it's a very high load on the phone. And it's not the only thing that we actually need to do. While we configure the camera, we need to do a few things in parallel. Camera is running, then at the same time, on parallel, we need to analyze the face scan, which is another bunch of load for our device. And then, that's not the only thing either. We also need to run the UI and not to make it frozen. So all of these three things have to be done at the same time while we're doing the face scan. And this is hard. It's not easy and it's not obvious. And I will tell today how to configure this. So first, let's go to set up the camera. We create a session. Just a moment. We create a session first. Then we choose, the session preset, which is supposed to be high. And then we will gonna do our scan with a front camera. So we have to say about it as well. And then we need to configure the output and deliver the frames in the BGRA format. It's gonna look like that, and let's try to run it on my device. So this is how the camera scan is going to look like. We have the FPS reflected on my screen. And basically on the screen, we have the mirrored preview because we are seeing the things as the camera is seeing them. And this is not obvious. We have to mirror the preview in order to get the picture that we get. Okay. So let's see how the camera input and output works. First of all, we get an input, which is the camera. Then we are running a session. And then out of these pictures that we are getting, we are supposed to get an output. What is the output? It's a bunch of frames that are returned to us in a BGRA format. In code, it looks like this. And what's important to know, that while we're doing all of this, we cannot do it, as I've said, at the same time, at the same place. So we need to do it running the background queues. Everything should be done on parallel and simultaneously. So we will have 3 queues doing that. First of all, we get a session queue. And the session queue is where all of the configuration happens. We start and stop sessions, set up the camera, and adjust the orientation. It's like backstage crew that prepares the camera before it starts. Then we get frames queue. And the frames queue is actually where the real work happens. So each camera frame comes, and we call the capture output, and inside that, vision detects the faces, validation logic runs, and we decide what to draw actually on the UI later. Finally, the third queue would be the main UI. So whatever we are doing on the back of the app, we have to then reflect and show it on the UI. We have to show the faces, contours, and make sure that it's all done at the same time. So what the user sees is actually the preview layer. It looks disconfigured like that in a code. And the preview layer is actually rendered directly by the GPU, so it's fast, it's a low latency, and we draw our overlays on top and give it to vision for coordinate conversion. This is how bounding boxes and the landmarks appear in the right place. And as I've said again, so since we're using the front camera, we need to enable the mirroring. So yeah, let's look at the session queue code. First, there is a configuration. It's never done on the main thread. We use a queue to start and stop the camera. And then the frames queue code looks like that. We wrap everything, and it's important when you use a frames queue to use the auto-release pool, because each frame allocates some amount of memory, and if it's too much, then the app will be killed because it takes too much of the memory. Also, to keep the camera being smooth, we need to use like always discard slate video frames set to true. And then the UI code is going to look like that. This is basically how to update the labels, draw the overlays, and refresh the FPS counter. So there are do's and don'ts that we can do in order to run everything smoothly. As I've said already, so what we need to do is actually run configuration and session management on a dedicated queue, usually called session queue, then process each frame, vision detection, validation, FPS counting on a separate background queue, and only update the UI on the main thread. And that's how the clean pipeline keeps everything responsive. What we don't do is that we don't run the heavy vision and validation tasks on the main queue, because that's how we will block the UI and it will be simply frozen. Again, we do not forget not to use the auto-release pool inside the frame loop, otherwise the memory will explode. And we never skip the always discard late video frames set to true, because that single flag saves you from a lag. Now, let's go to 2D scan. First, we have a camera set up with AVFoundation. It starts delivering frames, the raw images, frame by frame. And then, these raw images are actually saved in a CV pixel buffer, which is a low-level image memory. We pass each frame through the request handler. And then the result is actually shown in a result VN face observation. So now our camera is live, streaming frames. And yeah, that's how we detect the face and scan it in 2D. Let's look at the face detection request. So again, there is a camera frame, vision request, and face observation box, which is box and landmarks. And the vision detects the faces, and for each face it gives us a vision face observation. In code, it looks like that. We have a request, we have a handler, and then the vision detects one or more faces. For each face, it gives us a face observation result. Let's go further. Next, after we determined a face in the back of the app, we need actually to draw the face on the screen. And as I have seen you in the demo, there is usually a vision output. It is converted to UI kit space in pixels, and then we draw the contours. I put a piece of code that pretty much done like that. But drawing a face on the screen is not the same as validating the face. We can draw whatever we want, but what if the eyes are closed? Or what if we put just simply hand in front of our face? So we need to validate that in front of our camera there is actually a face. And I have put 4 checks in order to make sure that we are seeing a face in front of us. First, we check if the eyes are open. Then, we check if the face is visible. So you could see at the beginning of the demo, whenever I was not showing my full face, it did not pass the checks and the scan was not done. Then, the face has to be in a right position, so I cannot tilt my head too much. It has to be pretty much straight. And then, again, the pose should be straight, everything should be there. So in order to manage everything smoothly, again, we have to avoid main thread blocking. We have to run vision of the main thread using the dispatch queue and processing cycle in out release pool. We need to manage the memory properly as well. And I want to say that when I was doing this face scan, it did not run smoothly. So I had certain pitfalls that I want to mention. First of all, as I've said, I had the eyes problem because even though sometimes I was showing the eyes, the check was passing by even though my eye could be closed or I could just do like that, which is definitely not enough to scan the face. And what I did to figure it out, I added separate checks for each eye in order to make sure they are open. Then, the next challenge that I had is the angle problem. So the vision runs in a coordinate system. And what happens if I just turn my phone from portrait to landscape? It was another challenge, and it had to be figured out that the contours are actually followed the face. And the next problem has been the poor lighting, because if the lighting is pretty bad, then it's quite hard to see the face. And now in the code, so if the lighting is bad, then we are just showing a banner that please adjust the lighting in order for us to finish a face scan. And then, as I've said, the landscape problems that we had. Now, when we configured the 2D scan, we are coming to one of the most important things and interesting at the same time is 3D scan. So 3D scan that is done with the ARKit. ARKit can see the real world faces that are not flat, where we move our heads tilted, and that was not possible with vision. So how ARKit works? It's an interesting thing, actually. How do we, with our camera, determine the 3D face? So the ARKit is actually using the true-depth camera. And it's the same that is behind the Face ID that all of us use in our iPhones. The true-depth camera projects over 30,000 invisible infrared dots on your face, and it measures how they bounce back. So that's how it builds the detailed depth map of your face. And with ARKit, it's possible to blend shapes, tiny movement like blinking, smiling, and raising eyebrows in real time. ARKit actually puts higher load on the camera. So when I was doing vision, it was enough to have 30 frames per second. With ARKit, it's actually double. So we have to use 60 frames per second in order to make it work. So let's look at the code. The similar thing with the ARKit and Vision is that they're both run with the queues, with the session, and we create an AR view instead of camera preview. Once we configure AR face tracking configuration, framework automatically tracks your head in 3D. And every frame gives us an AR face anchor, which contains face mesh and blend shapes. And when the face moves, ARKit continuously updates an AR face anchor, so your mask can stick to your cheeks, follow your jawline, and stay perfectly aligned in any angle. So what did ARKit added to our face scan? First of all, it did something that the Vision couldn't give us, the depth. And geometry tracking. It understands 3D, not just a flat rectangle. It allows the mask to follow the face when turning or tilting the head, and without ARKit, the overlay would be just to slide around the screen. But ARKit is not always a perfect solution. So there are some limitations that comes with this technology. And first of all, that 3D scanning is not working with every model of iPhone. The true-depth camera started to be available only since iPhone 10. So it's an important thing because not everyone can use it. Then, even when ARKit works, it depends heavily on light and distance. So when we put camera too far away or too close, it's simply not able to work. And in those cases, the vision and 2D tracking sometimes is a little bit more stable. Yeah. So during the scan that I had, I used a timer that was set to 3 seconds, and the scan was complete in 3 seconds. Why did I choose this time frame? Well, first of all, it's not so long, and I think 3 seconds is a good amount of time for every user to actually complete the scan. It allows also the developers to collect several frames, average data, and to validate if the user is steady and if the eyes are open and face is actually visible. Yes. So, if we look at the technical insights, I really have a problem to navigate through the screen. Sorry, guys, about that. So ARKit gives you an AR face anchor object every frame. It includes both mesh geometry and 52 blend shapes like jaw open, eye blink left, and brow raise right. You can use those in real time to animate masks or detect the micro impressions. Everything on ARKit runs on the GPU, which means a very heavy computation. So ARKit gave us an incredible realism, but also it reminds us that sometimes it's simply not the best solution. So what did we actually learn when we did the face scanning? When we visualize the face on the camera with the contours, face visualization is not the same as face validation. So we can draw the face, but it doesn't mean that it's actually a face. We have to always run an extra check to validate. Then the second thing is that native APIs actually give precision, but it also has the hardware limits. So as I've said, TrueDepth's camera is available only since iPhone 10. And the optimal setup for face scan would be using a hybrid solution approach, so combining vision and ARKit native pipeline. And that's pretty much it for my talk today. Let's stay in touch with all of you. I have given my social media, whatever you prefer, and let's connect over there. And if you haven't scanned the QR code with the questions for the code, I have put it again once more here. You can scan it, and let's have a technical discussion over there. I think I'm running a little bit over time.
Yes.
So, yeah, let's ask the questions in the GitHub.
But let's start with a round of applause.
Thank you.